Now that we know how a binomial probability experiment works, of course, we're going to have to find some binomial probabilities. You knew that was coming, right? Okay, so there's this big, long, god-awful formula, but we're not going to do it that way. We're just going to make Excel do it. But if you're interested, that's how it works. So we're still considering Amber with her loaded die. Construct a sample space for the number of sixes that appear in 4 tosses of the die. All right, so let's start with what are the possibilities. So use Excel, I should say, and state the entries. Okay, so she could roll this die 4 times and get no sixes, right? Or she could get 1 6, 2 6s, 3 6s, 4 6s. Since she only rolled 4 times, that's the maximum number, right? Okay, so now what about Excel? How does Excel do this? Well, you know what? Let's actually go to Excel and figure it out. I'm going to make it bigger. Okay. Now, how Excel does this, and I'll figure it out over here before I type in the entry. So it's binom. Okay, let's get a little crafty here. Old school Excel. Excel before 2010, the 2010 version, used binom dist, B-I-N-O-M dist. Newest Excel uses binom dot dist. So they're the same function. It's just a question of binom dist. So it's the same thing. It's just the newer Excel version has the dot in there, but it'll work the same way. All right, so now what's the number of successes? Well, that would be 0, A2. Now, what's the number of trials? That's 4. What was the probability of succeeding? Rolling a 6. It was 0.9. And cumulative, we're just going to always say false in this particular example. Because we don't want it to add them up. We just want it to figure this out. So let me write out what I wrote. Binom dist A2, comma, 4, comma, 0.9, comma, false. Right? That's what we said. A2, of course, is the cell reference to 0. You don't have to do it that way. You can say 0. All right, so now what about the next one? That would be, actually, here's the beautiful thing about doing this in Excel. When you do it in Excel, because I used cell references, it actually knows all of the rest of them automatically. Crafty, huh? Look, see, so that one uses A3, this one uses A4. Cool. So we're done. We've got them all. And I'm just going to write that top one because the rest of them, it's obvious they'd all be the same thing, right? So you could say 0 for this one, and then you could say 1 for the next one, and so on. Or you can leave it A2, and then the next one would have been A3. Ugh, hold on. That's the problem with working with a laptop. It's so much harder sometimes to do it. All right, and this one would have been A3, and the next one would have been A4, and so on. All right. Are the outcomes in the sample space equally likely? Well, heck no. I mean, look, you're much more likely to have rolled 6s, so no, because the probabilities for the different x values, 0, 1, 2, 4, are not all the same. All right, so now we want to find the probability of exactly 1 6. Well, we already did that. It's 0.0036. Now I want to find the probability of at least 1 6. Now remember, we talked about that in chapter 5. At least 1 really means 1 or more. So the probability of at least 1 is going to be the sum of 1, 2, 3, 4, 5, and 6, which is 0.99999. Or you could do it with 1 minus probability of 0. 1 minus prob of 0. That would also work. But either way, it's 0.99999. See? There we go. So you could add them up, or you could use the complement rule. Either way, you're going to get 0.99999. All right, I'll see you here for the next page.